Alright everybody, it's almost the end of October. A couple more days and it'll be November 1st. And I'm back to work on the shaper project tonight. So I want to reinstall this adjustable fence and hood assembly. But it's got these adjustment rods on it, and they're pretty badly rusted and they're pretty seized up. So first order of business is I'm going to get this apart, and I'm going to go at these threads with a wire wheel, see if I can't clean them up and get them to work properly. I really don't want to use any oil or anything like that on these because it's just going to be something that sawdust is going to want to stick to even more. I don't know if these were originally coated with anything or if they were just regular, steel. Probably just regular steel. But anyways, so without further ado, get those rods off. Alright, so the way this works is this end of the rod is captive because this threaded part is a larger diameter than the hole through this part of the casting, and then the knob is placed on the back and it's pinned. Okay, so that this can't move, so when you rotate this is held in position and makes this move up and down. So the reason why I couldn't move it at all is because you've got locking bolts right here that you lock down once it's in position. So this is basically, it's a fine adjustment. Once you've got it set, then you lock it down with these. But I am going to want to clean these up anyways. So rather than try and lift this whole casting up over there with the wire wheel, I think the best bet's going to be to remove the handles on this. If I can get the pin. Okay, I made an assumption that was a pin, and I do now not believe that I was correct. I think now that actually looks like it might be an Allen set screw, which that's going to be, well, this ought to be good. Let's see if that comes out. Well, so far so good. Problem is, the rod doesn't stick out the back end of this knob by the looks of it, so it's not like you can tap it out that way. It's a blind hole, I believe. Well, if I had a small bearing splitter, that might work. I'll just see if I can use the wedging action of a screwdriver banged in there behind it to pop it loose. It doesn't look like it's moving at all. Grab a little liquid wrench and put a couple drops down. Yeah, I'll go with the PV blaster. And while that one's soaking, I guess I'll pull the that screw on the other one. Get some in there. Alright, the screw cleaned up pretty well. I want to clean up these knobs, and I think the easiest way to hold these is going to be to just temporarily put them back on the shafts here and hold this. Alright, now that I got the two threaded rods here cleaned up, I'm going to put I'm going to put them back in, but first I'm going to clean these two brackets here that they thread into. This one's not too bad, just a little bit of surface rust on there. So I reattached this bracket. I loosened this locking nut. I backed out the rod so that it's butting up against here, and I'm going to just reinstall the little set screw. And now this should actually move. Interesting. It doesn't want to. Loosen this side and see if with the rod out, if it moves. Yeah, that seems to be, that one moves freely. If there's any kind of a No, there's no kind of a pin or a slot that it sits in. So what's going on with this? The alignment's critical here or what? Something's wrong. This is binding in here. This is now completely loose. This is actually threading into here and it shouldn't. That's supposed to just freewheel in there. That's weird. I would think by design there should be a washer here. So if I wonder if I keep a space in there, does that make a difference? Okay, I can actually see the little witness mark where the set screw used to be. And I see another one here that's closer, so I must be putting this knob on too far. See if I can get that closer. All right, so if I leave more of a space in there, see if that corrects my issue. Well, there you go. And apparently I just gotta... Alright, that works. Not exactly smooth as glass operation. Alright, okay, so this assembly sits right on the top here, like this. And there's actually these two holes here that these long rods go down through, and they screw into a pair of threaded holes here. Now the interesting thing is, to me, is that there's two sets of threaded holes on the top here. Now, my first thought is that by design, there's two sets of threaded holes here because for larger cutters you might want to move this back. And let me illustrate that. If I use this set of holes right here that's up closer. In other words, if I use this set of holes here, oh, and by the way, I don't know if it's showing up or not, but this set of holes is actually offset from this set of holes by a little bit. Meaning either when they did this in the factory, I can't imagine by design they would want to do this. So either in the factory they screwed up and didn't get these lined up properly or didn't care that they were lined up, or somebody added a set of holes to this table, modified it. Alright, so what I was saying was that if I line up this fence on that set of holes that's closer up to here, a large cutter like the one that I want to use, this is a raised panel cutter that I want to use. This raised panel cutter is 5.5 inches in diameter. Well, it actually is too wide to even fit all the way into the throat of this thing. Okay? So I can't actually get this to line up with the spindle without it hitting the casting here and here. But I suspect that's why they give you the second set of holes here. I think the second set of holes is by using the second set of holes and sliding this back. I think that is so I can do this and use this big cutter on here. And I'll tell you what, even with that, it just barely clears the edge there. So I don't know what the maximum size, this is a 5.5 inch raised panel cutter, so maybe this is supposed to only be used on an even larger shaper than this. But this is what I've got, so this is what I'm going to try and use it on. The only other concern I have about having this back this far is I don't know whether or not the dust collection is not going to be as efficient by doing it this way, by having the hood, by having this hood back, this hood part right here. that is, you know, important for dust collection. That's actually behind the halfway point. But I think maybe if I just have a good enough strong vacuum on that thing, suction wise, it should work. I hope. This fence is held down to the table by these big long rods right here, threading on the end, with these big handles, almost as if to suggest that they expected you to be taking this on and off frequently. And I guess it's every time you wanted to do a cutter change or a spindle change. But anyways, these are really rusted, so I'm going to clean them up. And this one, the other one here, the plastic handle's broken. But I've got a fix for that also. Alright, so that's what that looks like cleaned up. That cleaned up really nice. I think it helps that there's it almost appears to be that there's some kind of a treatment to these metal parts that was done, so that all the rust ended up being, for the most part, surface rust. With a little bit of pitting, but on this wood shaper it's not going to make a difference. So I took this knob off, the broken knob, off of the shaft so I can repair it, and I'm quite fortunate that the way this broke, it broke into two clean pieces. In other words, when this broke out of this part right here, it didn't even break into small chips or anything. It broke cleanly into two pieces. So much so that I can actually put this piece back in exactly the way it was when it came out. There's one little chip right here that's not going to hurt anything. But when that's in there like that, it's so clean you can barely see the outline of the crack from the top. So that's going to really work to my favor. The nature of this piece being that it's cup-like in nature is going to really work out well, because I'm going to use an epoxy. Now, if I wanted to glue this, I would probably use Gorilla Glue. I've come to like Gorilla Glue for its strength. What I don't like about Gorilla Glue is its foaming that happens when the chemical reaction is taking place. And what you end up with is you end up with this messy stuff that oozes out that you've got to clean off later. And the other problem with any type of glue, any type of super glue, in this particular application, in my opinion, is that you're limited, your bonding power is limited to the surface area of this break right here. And over here you've got this big meaty area where, you know, you could get a lot of surface area there for glue, which would be great, but like on these edges here and over here, not so much. Although actually right there it's pretty good. But I think epoxy is going to be the better deal here, because what I can do with epoxy is I can literally put this piece in here like so, and there's nothing that says I can't pour epoxy into this up against that edge there and end up actually bonding to this much larger area that's available. So I'll probably put a little dab, just a very light liberal coating on this, insert this, then add more epoxy in there around the edges, and then just to keep this from moving out of position, I got this weight here. We're just going to put this weight on there like that when it's curing, and that should be plenty strong. So now I just got to decide what I want to use for an epoxy. So there are all different kinds of products out there on the market, but one of the products that I've used in the past for repairing plastic knobs, I mean in the long past, this stuff has been around. I don't know if they've changed the actual original formula much, but this Plast-Aid multi-purpose repair plastic. I forget where I bought this online, and I bought this because it reminded me of a product I used to use 20 years ago or more called Plast-Pair. And Plast-Pair, the original stuff that I first used was at a music store where I first started working on electronics, and Plasti-Pair came in a black and yellow box, and I forgot the name of the company that actually marketed it back then. But this stuff was fantastic for repairing like broken knobs on radios, plastic Bakelite pieces on old antique radios and things like that. So it was a great product for plastic repair on small knobs and things like that. And it's a two-part, sort of like an epoxy, where you've got an A and a B component. The difference with this stuff is that you've got one component is a white powder, and the other component is a liquid. So I ordered this stuff, and I thought, gee, I wonder if that's like Plasti-Pair, stuff of old. Well, I ended up taking the stuff and working with it and realized it had the same consistency, it worked the same way, and it even had the same odor as Plasti-Pair. So I'm quite convinced that this is the original, or very close to the original Plasti-Pair formula. Plasti-Pair formula, and that somebody has just gotten the rights to reproduce it and are marketing it under this Plastade. So, as great as this product is, I'm not going to use it for this job, and I'll tell you why. Because it's great for small knobs where you're not going to be putting a lot of torque or force on it. But this knob here, I think, is going to demand a little bit higher holding strength. And for that reason, I've decided I'm going to use DevCon epoxy. Now, I have DevCon epoxy. See DevCon up here, okay? Well, DevCon, this company makes several different varieties of epoxy. They are available in these self-contained dispensers like this one here, okay? But they are also available in the cartridges that can go in one of those guns you can buy. So if you're going to be doing a lot of work, you can buy the case. You can buy refills that essentially take this plunger away, and you just get this section right here. Let me get this out of here. You've just got this section right here, okay, and you load that into this special gun that comes with this particular one is a Loctite brand one, because Loctite also makes epoxies that come in this fashion. And I actually use this because the potting compound from 3M that I used on the repair of one of my electronics items, also on the alternator on the Mercury outboard, that came and needed one of these dispensers. So this is, completely reusable. You just keep loading new cartridges in here. And then you buy replacement, I'm actually out of them. There's a mixing tube that goes on the end of these cartridges. So unlike this product here, we've got to squeeze some of it out and then use a stirring stick and mix the A and B components together on like a piece of cardboard or something and then spread it on. Well, this here, it's all self-contained. It basically comes out, goes through a special straw, plastic straw with a auger in it that automatically mixes the two components. So at the end of the tip, it's coming out already pre-mixed, and you can apply it. So this is a great tool if you've got a lot of that stuff, or you're going to be doing it a lot. The problem is that the refills for those types of epoxies tend to come by the case. So again, if you're not doing a lot of it, you probably wouldn't want to invest in one of these things. Not that these are tremendously expensive. I mean, they're overpriced for what they are, but I think that about most things these days. So I don't think I'm necessarily the proper barometer for whether or not something's too expensive or not. I'm a cheapskate. So what I was saying was that the DevCon comes in several different formulations, and the one that I have that would be perfect for this application is called their DevCon Plastic Welder, I believe they call it. But it's a brand new tube. I haven't opened it, and I don't have any other jobs to do with it right now, so I don't want to open it right now and just use it for this little job, because you can see what happens when these sit around. Invariably what happens is these little plastic caps that you're supposed to be able to just push back on and reseal this for future use, they tend to, probably what happens is the stuff in here heats up and pressure builds up and pushes that little cap off the nose. And then what ends up happening is you end up with a big leaky mess. Now, if you're lucky, it just leaks onto, you know, the cardboard piece here and doesn't go much further. If you're unlucky, it leaks onto things that you don't want it to leak onto. And if you're real unlucky, both sides leak and mix and make a heck of a mess that ends up hardening. In fact, this has leaked. I just realized this is empty. There's barely anything in there. This thing has leaked out completely. So looks like I will have to open up the other stuff. Just for the hell of it. Pull this off, and if I push on the plungers, nothing but air. All but a tiny bit of the A component has completely leaked out, and all of the B component has leaked out. So that's useless. So here's the DevCon plastic welder, high strength. Well, I'll tell you what, the consistency of this stuff is way wrong. It's like bubble gum. It's not supposed to be. I actually don't even remember where I bought this. I didn't buy this tube new. This was with some other stuff that I bought. I remember thinking, oh, great. Unused epoxy. But now I can see that this stuff is way past. I don't know what the shelf life on this stuff is, but this is done. It's supposed to flow. It's not supposed to come out the consistency of bubble gum. Can't even get it to mix well. Oh well. Boy, I'm 0 for 2 on my DevCon epoxy here. This is actually a very good product. It just doesn't last forever. All right, so I'm thinking about the next problem I have, which is this is the spindle that I took out of the shaper when I was disassembling it originally. And the problem I have is that the cutter that I want to use, and again, this might be an indication that this cutter is actually too big for this machine, but the cutter I want to use, the diameter of the bore in it is much larger than this. So I don't know whether or not it would be okay to use an adapter on this or not. Now, I did read in the instruction manual that apparently these shipped with 2 spindles initially. And I remember thinking, well, I know I had a box somewhere and I had misplaced it that had some other stuff that came with the shaper when I bought it. And I was thinking, boy, I bet you there was another spindle in there. Well, the other day, well, not quite the other day, but a while back, I actually stumbled upon it when I was looking for something else. So I had brought it down here to the basement shop. I just cleaned up the spindle the other day. So this is the other spindle that came with it. The problem is, this is actually even smaller than this one. It looks larger, but that's because it's got these spacers on it right here. If I actually take these spacers off, the diameter of the spindle's smaller. This spindle has these spacers right here that go on it. So, these are the spacers that came with it. So, this is the larger diameter, which is still too small. So what I think I'm going to do is I'm going to make myself a bushing so that I can try and get away with using this cutter on this spindle. So what I'm going to need to do is I need to make myself a bushing that will take up that space in there. And as luck would have it, I actually had found this little piece of stock that I had laying around, and it's actually a perfect fit. So this must be a pretty standard bore size. Must be, I don't know, 1.25 inches or something. But I don't even need to turn this down. So I figure there's a couple of ways I could go about this. If I did have a piece that was oversized, what I would probably do is I would probably bore the hole through it first. That would make it fit this diameter. Then I would take the piece, mount it on an arbor between centers, and then turn the outside diameter down to fit that hole on the cutter. And the reason why I would probably do it that way is because then I would ensure that this outside diameter that I finish with is perfectly concentric to the hole that I bored. So, how am I going to do this if I've already got my OD and I want to create the ID? I want to create that hole. Well, if I put this in the chuck, okay, and then I just bore the hole, there is a possibility that I'm going to end up with a hole that's slightly off center from the OD, and I think that would be due to wear or error in the 3-jaw chuck. So I think what I'll do is, well, what I can do is this. I can clamp this in the 3-jaw chuck, leave enough of this sticking out so I can indicate and see how it runs. And if it runs out more than a couple thou, then what I'll probably do is I'll switch my chuck out to my 4-jaw chuck, put it in the 4-jaw chuck, indicate it and dial it in, and then do my operation. I think that's what I'll do. Alright, so I set up my Noga indicator stand with my Tessa Test 1/2 thousandths indicator, and it looks like I'm about 3.5 thousandths out. There's 1, 2, 3, and halfway between the next two divisions, so 3.25 thousandths out. And you know, I don't know, that might even be good enough. But I think I'm going to put my 4-jaw in and dial it in even tighter, just because, well, it wouldn't hurt for me to get a little practice in dialing in a 4-jaw. Thought this was the 4-jaw chuck for this, but I think it's not. Oops. Nope. This is more threads per inch. This must be a chuck that I got with the South Bend lathe that I scrapped. An old 16-inch cone head. Oh, wonderful. That's not good, because the only other 4-jaw I have, which I think is the one that came with this lathe, has no backing plate on it. I had forgotten that it didn't have one, or I didn't notice, I don't know. So, turns out, I don't think I have a 4-jaw for my lathe. Well, till I make a backing plate for the other one.